Question number 11, we want to find the length of the intercepted arc with the given central angle measure in a circle. We're given the radius and we want to round to the nearest tenth. All right, so the first thing we're going to do is look at the angle measure. And let's go to our unit circle and find 30 degrees. 30 degrees is, let's do that conversion. I thought I had the unit circle where it was converted. So 30 degrees over 1 times pi over 180. Okay, take off that 0. 3 goes into 18 6 times. 30 goes into 30 once, and 30 goes into 180 6 times. So this is pi over 6. All right, so now that we have this converted to radians, pi over 6, and I believe in your notes, let me check real quick that you got this morning. On the very back, you have the unit circle, and pi over 30 degrees is pi over 6. Okay, so we're going to take pi over 6. We're going to use this formula. S is the length of that arc. Okay, so the length of that arc is going to be the radius, 8 times pi over 6. So put this all in your calculator, do the multiplication, get your answer, and round to the nearest tenth. All right, now we have the angle measure in radians. All right, that looks like, I'm going to look at my paper real quick, 7 pi over 6. So 7 pi over 6 times 10. Same thing, round to the nearest tenth. I'm not going to give you the answer. You're going to need to do the work and then learn to use this formula. All right, let's look at number 13. The formula is for rotation and revolutions per minute. We're going to take our angular speed in radians, which we already have it converted to radians, but it's radians per second, and we want per minute. So the formula is simply to take this and divide by 2 pi. So let's start by taking 4/5 pi and multiplying by 60, because this is seconds, radians per second, and we want to know per minute. So there are 60 seconds in a minute. 60 times 4. Oh, let's do it this way. 5 goes into 5 once. 5 goes into 60, 12. 4 times 12 is 48 pi. So now that we have revolutions per minute, we're simply going to divide by 2 pi. The pi cancels, and 2 goes into 48 24 times. So your answer is 24. Now, if I reduce this, 4 goes into 32, let me see, 4 goes into 32 8 times. Remember, we're dividing by 4 in the numerator and the denominator. And 180 divided by 4 is 45. Cannot simplify that any further. And don't forget, we've got the pi up here. All right, now we're going to divide that by 2 pi. All right, now when we're dividing by 2 pi, when we divide by a number, we're going to put that over 1. We're going to flip it upside down and multiply. Okay, change this to multiplication and change this to the reciprocal. All right, the pi is going to cancel. And 2 goes into 8 4 times. And you have 4 over 45. We're going to multiply that by 100. So that's 400. Put that over 1. So that's 400 divided by 45. And let me get Desmos open and do the calculation. All right, we're going to skip to 16 and 17. I'm not going to do them all, so do what you can. Let me get my pen. All right, we want to find the area of each sector. So in your notes, we have this formula. Area equals 1/2 radius squared times theta. And we're going to use theta in terms of radian measure. Okay, so we'll start with theta. We've got pi over 6. So it's going to be 1/2 times 14. Okay, don't forget to square that, times pi over 6. Put that into your calculator, all of that into your calculator, and come up with the answer. You may need to round that off. Okay, do the same thing for this one. I think this is 7 pi over 4. Okay. All right, I'm not going to do it all. Just do what you can, and we'll go from there. All right, don't stress on that too much because this is something new that I'm seeing for a lot of you. So just do what you can. We'll turn it in and we'll go from there and build it. We're not going to stress out about that at this point. Just go back into the PowerPoint, use the formulas, go back into your notes, use the formulas, and do the best you can.